line, and this is a beautiful view of the mountains. I can see off in the distance snow-capped mountains. I guess that's in Nevada. But I don't know, we got to cross Hoover Dam in 13 miles. But this is some really pretty country. Wouldn't like to live here, too dry. This morning is cold and windy. I'm sure the wind will be in the on the tape, the noise from it. There's some water down there. I think that's a lake. I don't think that's the Colorado River. As a matter of fact, I'm sure it isn't. Let me put some date on here. Okay, March the 6th, 1990. And this is Eastern Standard Time on the film here. It says 1:08 p.m., but actually we'll be going into Nevada and it'll be just 10:08. Get back over here and get the snow-capped mountains again if I can. Okay, there are the snow-capped mountains. Where are you going, Bob? Stand
I didn't know you was putting me in there.
Trying to get you in on it. You were backing up.
Time while you're underneath the water. Behind you, separating you and Lake Mead, is a concrete wall more than 100 feet thick. The height of the dam is 726 feet. It is 660 feet thick at the base. If you think about that for a moment, if we had the ability to turn it sideways, it would still be just about as high as it is now. There are 3¼ million cubic yards of concrete in Hoover Dam. It weighs 6,600,000 tons. That's enough concrete to make a standard two-lane highway 22 feet wide from San Francisco to New York. These floors are terrazzo, that's concrete with polished marble chips. Designs are composites of Indian designs which were inspired by the designs of the Southwest Indians. Perhaps you've heard two names for the dam. It was originally and officially named Hoover Dam. The planners considered putting it in Boulder Canyon, 11 miles upstream from here, so they nicknamed it Boulder Dam. Then they determined that Black Canyon, which is right here, was a better location. The dam was built here. People continue to call it by both names. It was mostly known as Boulder Dam for a good number of years. There's a great deal of political controversy concerning the name. Franklin D. Roosevelt ignored the name of Hoover Dam and dedicated it as Boulder Dam in 1935, the year the dam was completed. So the controversy continued until 1947, when President Harry Truman told Congress to straighten it out. Congress looked into the situation, then said it was officially named Hoover Dam in the first place, and that it would and should be called Hoover Dam in the future. Therefore, in 1947, the name Hoover Dam was restored. There are three main purposes of Hoover Dam. First is flood control. Second is the regulation of water downstream so they can have a regular supply for their needs down below. Third, and it is a byproduct, is the generation of electric power. A very important byproduct. A little more than 55% of the power that we produce here goes to the Southern California area. 9 cities down there get a small portion of the power that is allotted for Southern California. The remaining approximate 44% is divided between Southern Nevada and Western Arizona. Contrary to what you may have assumed, we do not light up Las Vegas nor the Strip. Las Vegas gets only about 4% of the power that it needs from Hoover Dam. It was just a watering stop on the railroad back in 1930. Now that the population has grown, it must get most of its power from some steam generating plants in the general area. Here comes our third group. We'll be on our way in just 1 minute. Units are approximately 7 stories high, 30 feet exceeds the generators, 40 feet below the generator floor level are the turbines, rating is 100, generating more than 2 million horsepower, and developing 1,800,000 kilowatts at the current stage of upgrading. The shaft, as you can see through the lighted window of the first generator, is 65 feet in length, 38 inches in diameter. It weighs more than 100 tons. In all, there are 800 tons of revolving weight in each generating unit, traveling at a speed of 180 revolutions per minute. Each unit contains 60 railroad carloads of material and required 3 years to manufacture, assemble, and install. The lights on top of the generators tells us which ones are in operation. These are for other plant services. Low body. Overhead, you may see the 2 green traveling cranes, one at each end of the room. Each crane has a lifting capacity of 300 tons. When they're yoked together, they can lift 600 tons. They were yoked together several weeks ago. The rotor was closed with the number 6 generator, and now that rotor is sitting down here in front of you. They've been in the process of completely rebuilding this generating unit and putting in new transformers outside. We have 11 of these units completed now. We expect they'll all be completed by 1992. When this job is finished, Hoover Dam will produce at least 35% more power than it did when the upgrading began and produce more than 2,000 megawatts. Please watch your step and use the handrail. We can follow me down the stairs. Follow.
These are the big generators. I'm standing on the ground floor. And there's some people there. You can tell how big they are.
700 volts. The transformers can step it up to 287,500 volts. The water over the side is a tail race. In normal years, all water that goes downstream goes through the turbines. The water will vary from 30 to 60 feet deep, the temperature from 52 to 55 degrees. Automobiles and trucks come in over on the other side where you see the tunnel with the light bulb shining. Farther down is a bridge and a roadway connecting with Highway 93 on the Nevada side. That's the way the vehicles come in for plant service. Above the tunnel is the concrete structure with the 6 round holes. In the early days, when only a few generating units were in, only a limited amount of water could go through the generating units, oftentimes not enough for their needs down below. So needle valves were inside those holes. They would open the valve to let additional water go downstream to meet the requirements for water down there. In later years, things changed when all of the generating units were in, and always plenty of water could go through the generating units. Excuse me. So those valves were no longer needed for that purpose, and most of them were removed. The rock walls rise about 600 feet above you. Then I'm pointing to what was formerly the world's largest cableway. These 6 cables are 3 1/2 inches in diameter and have a rated lifting capacity of 150 tons. They were upgraded at one time to lift 200 tons and used during construction times to lower loaded railroad cars and other heavy objects to the rails upon which we're standing. The cableway was last used for freight cars in 1961 when the last generator was installed over on the Nevada side. After that, the railroad tracks were removed from the roadway above, but the cableway is still used today for heavy objects. Farther to your right are the transmission towers, which lean this way at an angle so that the transmission lines will not short out against the bank. Farther still to your right, you're looking at the face of the dam and the 4 large towers at the top. The 2 center towers are elevators. We came down in the one on the left in Nevada. We'll return in the one on the right in Arizona. The state line comes down the center of the dam between the towers. However, the states of Nevada and Arizona have no authority over the operation of Hoover Dam. The many horizontal lines across the face of the dam are 5 feet apart. They are form lines that were made when the dam was built. The screened openings are the ends of inspection galleries, similar to the one through which we began our tour. The large windows are in the offices and the control rooms of the power plant. Now we're going into the Arizona Canyon wall to visit a penstock tunnel. Please watch your step. Volcanic rock. They are natural springs. They are not seepage from the dam. To build the dam, it was necessary to divert the Colorado River, which flowed in this direction, and to dry up the dam site. To do this, the men blasted and drilled 4 tunnels, 56 feet in diameter, through solid rock. 2 on the Nevada side, 2 here in Arizona. The 4 tunnels were lined with 3 feet of concrete, and a dam of dirt and rock 100 feet high was placed at the upper end of the site to divert the waters through the 4 tunnels. A second one 65 feet high was placed at the lower end to stop the water from backing up. Then this area was pumped dry, and it was necessary to excavate 135 feet down below the riverbed to solid bedrock, then construction could begin. This process began in 1931. Construction was completed in 1935, with the first of the generating units went into operation in the fall of 1936. This was all 2 years ahead of contract schedule. The dam was built in vertical concrete columns, as it shows in this photograph. Forms were made of wood 5 feet high, and pipes with refrigerated water were run through the concrete to cool it down. If this were not done, it would have taken at least 100 years for the dam to cool and to cure, then it wouldn't have been any good anyhow. Contrary to any rumors that you may have heard, no one is buried in Hoover Dam. However, 96 men did lose their lives. It was dangerous work. They were excavating, blasting, drilling. They were high-scaling out on the canyon wall in extreme heat during the summertime. The men were working around the clock, and at the peak of construction, more than 5,000 men were employed, with a total of 16,000 over the 5-year construction period. When all factors were considered, the authorities felt that they have had a pretty fair safety record. When construction on the dam had advanced far enough, steel gates were placed across the entrance of the tunnels, and lake mead began to form. The upper sections of the tunnels, which are colored yellow in the diaphragm, would be below the water line as the water rose along the canyon wall. To keep keep them from deteriorating and leaking. Concrete plugs 400 feet long were placed here. And these sections of yellow were abandoned and served their purpose. The lower sections were used as part of the permanent project. The outer ones in gray are the spillways. In normal years, they are standby. They were standby for 42 years, up until the summer of 1983, when water went over the spillways because of the tremendous runoff from the Rocky Mountains. The inner tunnels were used to run the penstocks through. The penstocks are the 30-foot pipes which carry the water. You're standing over one of these penstocks right now, and here's where you are. You're right here. The yellow line indicates the tunnel that you just came through. The rumbling noise is water going through this pipe, which is full. The pressure is about 240 pounds per square inch. The pipe overhead draws air from outside below and releases at the upper end of the tunnel so that a current of air moves down this way to keep the humidity in the air from condensing on the outsides of the pipe. No water goes over the dam, under the dam, or through the dam. All water goes around the dam through these 4 penstocks. To make sure that no water ever does overtop the dam and spill down onto the power plant, this spillway system was built, which works like the overflow of your bathroom sink. Each of these was designed and built with the determination that it could handle 200,000 cubic feet of water per second. That's more than enough to handle any flood that ever had come down the river. Each of these can handle as much as the average flow of water that goes over Niagara Falls. We never have had that much water. I'm sure that we never will have, but each of these can handle that amount of water. To get the water to the turbines, intake towers were placed on rock shelves on the edge of the riverbed. They are 395 feet high. The tops stick up to where you can see them from the top of the dam as they stand out in the water. You'll see clocks on 2 of them. 30-foot pipes or penstocks were attached to the bottom. Water comes around the dam and branches off through smaller penstocks, 13 feet in diameter, leading to the turbine. It causes them to spin and turns the generators. That's what produces the power that we generate here at Hoover Dam. When you looked out at this penstock, you can see that it was big, 30 feet in diameter. That's big enough to build a 3-story building inside. At our exhibit building on the Nevada end of the dam, you can see the photograph which shows the locomotive engine standing inside the penstock section. Because these pipe sections were so large, it would not have been possible to build them someplace else first and then ship them across the country through the railroad tunnels. So that problem was solved by building a fabricating plant 2 miles up from the Nevada corner of the dam. There, the pipe sections are made of cold-rolled boilerplate steel 2 3/4 inches thick. Each 22-foot section weighs 150 tons. Some sections weigh 187 tons. They were built up there, loaded onto a special trailer, brought down the roadway, lowered over the side by the cableway that I pointed out outside, and brought into the lower end of the tunnel. Then they were fastened together with steel pins weighing 13 pounds each. These pins were hydraulically compressed from the inner side of the penstocks into heated holes so that a good tight fit could be had. Then the pipes were coated inside and out with an enamel coating so that deterioration would not take place. Hoover Dam and its many related projects were built at an approximate cost of $175 million. That included a lot of things. The All-American Canal down near the Mexican border so they could handle the regular flow of water that was available after the dam was built. All the roads and the railroads that came into this area for the building and the sustaining of the different projects. The original town site of Boulder City, the dam, the power plant, the tunnel linings, the intake towers, the exhibit building, all that for $175 million. How's that for a bargain? Is that pretty good? And now that's been repaid plus interest through the sale of electrical energy. But we don't know what it would cost to build the dam today. There's no doubt that it could be built. We just don't have any figures on it. Your guess is as good as anyone. If you make a guess, I'll agree with you. Please give me an aisle through here. Let me lead the way up these steps. I'll be waiting at the service elevator in the power plant if some of you need to move to the balcony above. You have the same number of steps to go up that you came down. If you do need the service elevator, please let me take you to the balcony above.
This is a spillway. The last time it overflowed was 1983.
Took a while, I was working.
I asked the guide if it was dangerously low, and he says no. Says, as a matter of fact, it's where they like it. But you can see how far below the water line it has been.
It's identical to those.
How long will you tell
Now.
me on?
Okay, what's the name of your bow?
Moret.
Moret.
As I told you, he's dead now. This girl's still making the bows, but he don't make them anymore. Forward handle,
And what inch hour do you shoot?
26 and a half.
Boy, that is a light arrow.
1913.
Uh-huh. Boy, it stays on there nice. What, is something holding it?
It's just the rest, TM Hunter rest.
Oh,
The little prong.
yeah. Yeah. Normally you'd what, a 31 or 32 inch
31
draw?
and a half is what I was using before.
Yeah. Well, that's all right.
Operational areas are in.
I'll never try to force myself. I'll put my hand out like that. If they don't want to come, fine. If they do, usually you can tell right quick if the dog's going to be friendly right off the bat.
I usually get along with
He's
most
very
dogs, but
friendly
there's
at the beginning.
a
He's a little standoffish, but he makes up real quick.
there's a dog in back of us.
Jeez, my stomach
that
broken
is
out. Do I look
loud,
gorgeous?
and it
Yeah, she went to go to sleep.
you can stop